The last two types of factoring questions are on your chart, the ones that are 3 terms and 2 terms. So we're finishing off the chart. We're going to talk about perfect square trinomials, and you guys are going to find these formulas very familiar. Remember when we did special products? It's actually just the opposite. So the idea behind this is whenever I give you a trinomial that has a perfect square for the first term and a perfect square for the second term, and the middle term is 2 times the first term and the second term, then there's a very, very, very good chance that the answers you're going to get are 2 binomials that are exactly the same. You don't have to follow this rule. Again, you can just FOIL just the way you've been doing it. However, if you recognize this, it makes the question so much easier. So I'm going to show you 2 examples using this little technique and this little trick. You look at the first question, it looks like a regular old trinomial, right? It's a complex trinomial. You can't factor anything. However, just as a review, let's practice our perfect squares. So we have 1, and we have 4, and we have 9, and we have 16, 25, 36, 49, et cetera, et cetera. So as soon as you see one of those numbers, 64, my pen's not working, 81, 100, my pen's not working. You know what? I'm just gonna stop sharing and then restart because I'm writing. Okay, so in this question, I can very clearly see that I have the number 4, which is a perfect square, the number 25, which seems to be a perfect square. Now, if I just do a little bit of quick math here, I know the square root of 4 is a 2. So I'm just going to write, and I'm not solving the question, so I'm just showing you what I mean. The square root of 25 is a 5. And if I multiply those 2 numbers, 2 times 5, I get 10. And if I multiply that by 2, I should get the middle term. So is 2 times 5 times 2, 20? Yes, it is. So this is an example of a perfect square trinomial. And when I have an example like this, in order for me to factor it, I'm not going to do any of my old tricks. I'm just going to go ahead and guess the square root of each number. So the square root of 4 is a 2. That means it's going to be 2x and 2x. The square root of 25 is a 5. So it's going to be 5 and 5. And in order for both of those to be positive, according to my little rule up here, these have to be plus signs. Now, this can be your final answer. You don't have to do anything else. However, in some textbooks, you may see these rewritten as 2x plus 5, everything squared. It's the same thing. You can leave your answer in either form. Okay, so identifying that it's a perfect square trinomial makes the question so much easier. Question? You don't have to show any work other than this. Yeah. In fact, I feel like factoring is all kind of weird because you really don't have to show much work. Okay, let's look at question number 2. 9 is a perfect square. 49 is a perfect square. If I just do a little bit of calculating, I know the square root of 9 is a 3. I know the square root of 49 is a 7. 7 times 3 is 21, and 21 times 2 gives me the middle term. That means this is a perfect square trinomial. PST for short. So how is this helpful? Well, we don't need to do any guess and check. I know what the numbers have to be. So I'm going to go ahead and start writing them in. The first 2 numbers are going to be 3x and 3x to give me 9x squared. The second 2 numbers are going to be 7 and 7 to give me 49. And I know that if the middle term is negative, that means both of these have to be negative as well. And of course, you can FOIL this again and see if it works. So 3x times 3x is 9x squared. Negative 21 minus 21 is negative 42. And negative 7 times negative 7 is positive 49. You can keep it written like that, or you can go the additional step and just square it. I'm going to give you and your partner 4 minutes to go ahead and identify which one of the following 9 questions are perfect square trinomials. And if they are perfect square trinomials, factor them. So about 4 minutes to try this. All right, so we just did this activity. We found out question C, question E, and G, and H are perfect square trinomials. Just bring a special attention to question A and F. They seem to be perfect, except the signs are positive and negative, which doesn't match the pattern. All right, you guys, to finish off our factoring review, we're going to talk about difference of squares, which tend to be my favorite type of factoring. There are three things I look for when I'm trying to factor something using a difference of squares. First of all, I'm looking to see if the numbers I have are perfect squares. Then and if sometimes you may have to take out a greatest common factor before they become perfect squares. I'm looking to see if I only have two terms in the question, because a difference of squares will only have two terms. And the last thing I'm looking to see is if there is a negative sign in between the two questions. So if these three conditions are met, then it's likely a difference of squares question. And to factor that, basically, you're just going to get two conjugates. Remember, we talked about that word a couple of days ago. Conjugates are when you have the exact same numbers, except one's a positive bracket, one's a negative bracket. Sarah? So sometimes you'll have two terms that are not perfect squares, but if you take out the greatest common factor, it will end up being a perfect square. Yeah, and we have a couple of examples like that. So let's look at example number 1 here. Let's see if all of our conditions are met. So we'll do a little checklist. Is 1, by the way, a perfect square? Yeah. So 1 and 36, they're perfect squares. So check. There are only two terms, check. And there is a minus sign between them, check. This is definitely a difference of squares question. And to factor this, all I'm going to do is I'm going to look at the first term and take the square root of it. So the square root of x squared is just an x and an x. I take the second term and I take the square root of it. It's going to give me a 6 and a 6. I don't need to do the double smiley or anything. I know one of them has to be a positive and the other one has to be a negative. And that's it. Question? Yeah, for these questions, absolutely, you can change the sign. It will not matter. Okay, let's try the next one. 9 and 16. Are those perfect squares? They are. Are there two terms? Yep. And is there a minus sign? Yep. So again, another example of a perfect square trinomial. What am I saying? A difference of squares question. So I'm going to take the square root of 9x squared, which will be 3x and 3x. I'm going to take the square root of 16, which will be 4 and 4. And then one of them will be a plus and one of them will be a minus. And you can FOIL this and see for yourself if it makes sense, but these questions will always work out where that middle term just disappears. And so that's why you don't need a middle term. Okay, question number 3. Are 2 and 18 perfect squares? No. However, do you see a greatest common factor? Yeah, so we're going to take out the greatest common factor. And now inside the bracket, we have two terms with a minus sign, and both of them are perfect squares. So to factor it, I take the square root of the first term, I take the square root of the second term, and I'm done. For question D, do we have perfect squares there? Nope, we can take out a greatest common factor though. So let's take out a 2. And now they are perfect squares. Plus you have an extra variable. So it's going to be 2x and 2x, 3y and 3y, and then a plus and a minus. Okay, Last two questions. Okay, question 5 and 6 are a little interesting. So let's take a look at question number 5. In this question, we have a difference of squares. So we're going to factor it just like we did before. It's going to be x squared plus 4 and x squared minus 4. Because when you take the square root of x4, you're going to get x squared and x squared. And the reason why this is interesting is, can we continue to factor this? Yeah, but we can only factor one of the brackets. Which one of the brackets is a difference of squares and which one is not? Bea? Yeah, so this bracket here, it ends here. There's nothing else you can do to that one. However, this bracket here is another difference of squares question. It has two terms, a minus sign, and both of them are perfect squares. So you have to remember to continue. If you don't, you do only get part marks. And how do you know when you have a question like this where you're going to have to continue? Well, I always say when your x is something other than a square, like if it's a 4 or an 8 or something like that, then you're likely going to have to keep going. So just be mindful in a difference of squares question. If you have an exponent that is bigger than 2, you can keep going. All right, last question. I'm going to use substitution for this. So I'm going to let a equal to x minus y. You don't have to use substitution. Some of you may be able to just solve it and see it directly. When I do that, I get 9a squared minus 4. And so this is going to be 3a plus 2 and 3a minus 2. And then at the end, I'm going to bring back what was my a. So it's going to be 3 bracket x minus y plus 2 and 3 bracket x minus y minus 2. And distribute. That's it. So your work for this section is again 28 questions, but they'll go